Hello everyone. In this video I will explain small extension to Kube-Scheduler which I wrote in Python. Before starting I want to say at the end of the video I will push all changed codes and I write like a description to the YouTube where you can get all these code files. And before starting I want to explain a little bit theory stuff, why I achieved this to write these codes. So just imagine you have some deployment which you are going to apply to Kubernetes. Kube-Scheduler only at the first time will calculate resources from Kubernetes worker nodes of compute resources where it can allocate new deployment replicas. So even if you will write pod affinity rules with required and scheduling, it will not help us, because in preferred state in affinity rules it means you are going to apply, split each replicas per worker, but it's not hard requirement, it's soft. But in case of required, it's going to be equal, like as Demon said. If you have only one worker in ready state, it will allocate only one replica inside of one worker, but two of them will be in the pending state. It will not work. But to do that, in most cases, we will use preferred, like as soft requirement where we can use. Of course, at the first initialization time, Kube-Scheduler will try to allocate each of them per worker. But I will simulate, of course, all this stuff to see what's happening. And do that, I wrote code which first, each minute, of course, you can configure current job for your requirements. I think in on-prem servers, if you will have 3 workers, in 90% it will help to you to allocate each replicas of your deployments per node. It will help you, I think. So in Google Cloud, it doesn't matter. In any cloud, you will not face this issue, because inside of clouds we have cluster autoscaler to create workers on the fly, and at the same time in Google Cloud too. So it's not a big issue in case of the cloud. So to do that, I wrote current job, which by default is going to collect information from workers. If only one worker in ready state, it will not do anything. If more than one worker in ready state, it's going to collect information from namespaces. If inside of namespace it will find annotation with this key and with this value, it's going to collect all deployments for each namespace where this annotation present. And if for each deployment replica count will be more than 1, it's going to get information per each deployment where the pods are located. If the pods are located only inside of one worker, it's going to do rolling restart to this deployment. So I will not go too in-depth to show the codes, but even from names we can understand what I'm going to. Getting unique names, deployment, unique nodes for deployment inside of namespace, restart deployment, its functions which I am using. At the end, restart deployment if needed, get ready nodes, get deployments in namespace if of course annotation present, and get annotation from namespace to be sure I must collect information deployments of this namespace or not. So just I want to say, of course this current job need access to collect information from Kubernetes API, and do that we need this access to give my current job which I wrote. So I will close variables part. Only one thing I want to say. This label required to understand which of the nodes is master nodes and exclude the master nodes from the search. So I will close the variable 2. Little bit I want to say about affinity, which I said before. So if we use preferred, as I said before, it is soft requirement. If we use required, it is hard requirement. Right now I will simulate it to show what does it mean. So just look at this. We have case where get nodes, R1 nodes. I've disabled this to simulate, of course, just to see. We have we have 3 workers, 2 of them in scheduling disabled state and 1 of them in ready state. If I will try to apply deployment with affinity and try to see, just look at this part. One of them are located inside of worker 3, which is in ready state right now, but two of them in pending state. As I said before, if we use required key, it means it will be equal to the daemon set and will not be allocated to any place. It is trying to allocate per each worker where is ready state one replica. Do that, it's not useful. In most cases we will use preferred than required, and I will delete this. Try to show you nothing changed deployment which I am using right now. So inside of this deployment, as we see, I'm using soft required, preferred I mean. So with this key, Kube-Scheduler trying to allocate each pod per worker if they are in a ready state. If not, it is soft requirement. It will allocate each replicas only inside of one worker which is in a ready state right now. So right now we have get nodes, if I will do one worker in ready state, and the code which I wrote, cron job, not in active state, I will do activation and to see log output. In case of only one worker, it will not do anything, I mean in ready state. If I will do patch and to see the log output of the code which I wrote, as we see it says only one node in ready state, no action taken, because if only one node in ready state, we don't need to collect any information, analyze it, and do that. Right now I will do kubectl on cordon worker 1 and worker 2 and see log output. So after 25 seconds, another pod will be created, and we will see here rolling restart of the pods will happen. Just I will not do pause because we must to see in real time. So container creating, if I will analyze. So as we see, container restarting start happening right now. So we will see to the logs. Just 1 second. I want to show all stuff and then switch back to see full log output of the cron job. So as we see, each of the replicas are located in workers 321, because we used soft requirement of the allocation inside of affinity rule. So I will go to show log output. Sorry. Oh. So as we see, it says we have 3 worker in ready state, information from namespaces which we collected. So right now it says I found 4 namespaces with annotation which we defined inside of variable, and it is going to collect deployment, analyze the count of the replicas which workers works right now in ready state. If all of them works in one of them, it's going to do rolling restart. So if I will get namespace, one of the namespaces to see, as we see we have annotation with the collect deployments allow state. So that's it actually. I hope it will be useful to all of us.